Good morning. Can you hear me at the back? Good. I'm not being made fun of like the previous speaker, so that's good. Apparently, I have not the first clue what I'm going to talk about here today, because according to the Stack Overflow community, I have no reputation on PHP Unit. But hopefully that is going to change soon. So, hi, I'm Sebastian. I've been doing things with PHP and to PHP for a lot of years now. I started in 98, 99, back in the dark ages of PHP 3. I missed PHP FI. I think I'm glad for that. And nowadays, I help teams to successfully craft the right software that makes their business happy, their customers happy, and so on. I do this with a company that I founded a couple of years ago together with two good friends that are also active in the PHP community, and that's as much advertisement as you're going to get from me. So, the state of PHP Unit. This is something that I like to talk about, usually in the hallway track of conferences, and for the first time try as a real presentation. So let's look back a little bit at the history of the project and what we've done over the last 12 months and what's soon to come, because next week is once again release week, but more on the new release process in a little bit. So looking at the past. This is the oldest evidence in version control that I can find for PHP Unit. I don't remember when exactly I started to work on PHP Unit. It was about at least half a year before that initial commit. Back then it was still CVS, which at some point got converted to Subversion, which at some point got converted to Git. Yeah, so summer of 2001. Around that time, I was exposed to JUnit and unit testing and test-driven development at university. I was really lucky that I had a professor who was friends with Erich Gamma and also knew Kent Beck and introduced his students, me including, to JUnit really early on. He knew that I was doing things with PHP at the time, and he said, I see that you're really excited about JUnit and unit testing, and PHP does not have that. Will you come over to Java now? Because we have this tool. I said, no, there's no reason to switch the language because I like this language much better than Java. Somebody just has to build a tool. So that's how it all started. Fast forward a couple of years. These are not the current numbers, but I'm not sure that they changed over the last week when I created them. For a really, really, really long time, back when PHP Unit was still developed in CVS and then Subversion, I was more or less the only contributor or the only person working on it. I got some patches along the way, but the metadata about who made this patch and when got lost along the way because we didn't have that possibility without a distributed version control system. Only when I moved development of PHP Unit to GitHub and Git a couple of years ago, the number of people working on it increased dramatically. It's more or less people that send 2 or 3 patches to fix a particular bug. But over the years, people like Jeff Welch or Volker or Michael Lively contributed significant parts of PHP Unit. So thank God it's not just me anymore. So what happened in recent history? I'm not going back all the way to the beginning, going back as far as September 2012, which was when PHP Unit 3.7 came out. And I don't remember any of the new features that were introduced in PHP Unit 3.7 off the top of my head. But the 2 important things that happened with that version of PHP Unit was that for the first time, there were 2 additional distribution mechanisms, installation methods officially supported by the PHP Unit project, other than the pair installer. It was the first time that PHP Unit could be installed using Composer. It was the first time that we were able to package PHP Unit as a PHP archive, as a single file that contains all that you need to run PHP unit. So that was PHP unit 3.7. About a year ago, PHP unit 4 came out, which had some major new features, but that was not really what warranted the bump in the major version number. But we changed, among other things, the release process. Before, it usually took 2 to 2.5 years for a new version with new features of PHP unit to come out, which was way too long. Led to a couple of kind of broken 0.0 releases, that because people don't test release candidates. They wait for the final version and only then try it and then complain that nobody tested the release candidate. So that's what we changed with PHP unit 4. Since PHP unit 4, there's a new version of PHP unit every 8 weeks. And kind of at the same time, when PHP unit 4 came out, we announced that by the end of the year, by the end of 2014, we would shut down the pair.phpunit.de pair channel server for PHP unit. And I was really scared on December 31st last year when I turned it off, because I expected a major shitstorm to happen, but nothing. Although there were still, on an average, Monday to Friday, 10,000 downloads of PHP unit per day via the pair channel, nobody complained. I have no idea how that matches. Those 10,000 downloads per day, they were not using the pair installer natively. It was just Chef or Puppet scripts, recipes that downloaded the tar archives of the pair distribution and magically did something with that. And about 2 months before the final shut off, I saw that there was still that much activity on it, and I don't know what we as a project could have done more with communicating that we're going to shut this off. So as a last resort, I made one final release of PHP unit as a pair package that did nothing but just die on the command line, tell you, you install the version of PHP unit that does not work. If you want a version that works, use the newer distribution mechanisms. That did not help. But apparently, finally shutting it off helped. There was no backlash, no outrage. Everything went smoothly. I'm still surprised, but okay. So we changed the release process. PHP unit, starting with PHP unit 4, follows semantic versioning. A new stable release with new features is released every 2 months, which makes it much more interesting for new developers to contribute new features. Before, it was really frustrating. You had worked on these fancy new features, and the patch was accepted. And then if there had just been a new release, you probably had to wait 1.5 or 2 years to get your feature into a stable release so people can actually use it. So that was very frustrating for everyone involved, and that's why we completely changed it. So new stable release every 2 months. The support for PHP unit 4.4 ends when PHP unit 4.5 comes out. So there's no support, no bug fixing for PHP unit 4.4 once PHP unit 4.5 is out. The support for PHP unit 4 will be guaranteed for at least a full 12 months after PHP unit 5 is released. Stable releases of PHP unit are, in addition to packages where you can download it, where you can manage it via Composer, stable far archives are archived at these URLs. There's a symlink to the current stable release at far.phpunit.de/phpunit.far. Just download it, run it, and you have everything you need for PHP unit. As part of the release process, every 2 months, just when the new stable release has just been published, we create a new branch for the next version. And every night we take the current state of that branch and release it as a nightly better quality build, which you can download from far.phpunit.de/phpunit-beta.far. Now here's the thing. We've been doing these nightly builds for almost a year now, and so far only gotten one feedback based on these nightly builds, which is why last week I raised the question in the GitHub ticket and on Twitter whether or not having this phase actually makes sense. If we don't get any feedback out of it, then why go? Well, we already went through the trouble about a year ago when we set up the build automation for this, so there is no trouble involved right now because the machine just keeps happy building on the packages every night. But why do this if nobody actually uses them? And there's some interesting discussion going on there. So maybe we keep them, maybe we get rid of it. I'm not sure yet. And also, every night there are builds from master, what's currently being worked on. So new features are developed in feature branches. When a feature is ready, the feature branch is merged onto the master branch, and every night there's an alpha quality build that you can download as a FAR to play with. Now for those, we actually do get feedback. So that's something that's useful. So to give you an overview, PHP Unit 4.4 is the current stable release series. It became stable on December 5th. PHP Unit 4.5 is currently in beta. It will go stable on Friday. And on Friday, we start the stabilization phase for PHP Unit 4.6. And it will become stable on April 3rd. So every 2 months, first Friday of the month is the new stable release. And with that, we actually had good experience last day of the week. Makes it much less likely for people to install something and then go off for the week and then break everything. So the present. Well, PHP Unit 4.0 came out in March 2014. It brought, among other things, support for HHVM, which from time to time is broken, which is why on Travis we're still excluding it from the build. Sometimes it works, sometimes it doesn't. She looks confused. I'm confused most of the time. And at the moment, I don't care enough about HHVM to invest serious time into figuring out why it doesn't work.
We care about PHP units, so
yeah, I know.
We'll work on that.
That's good. So, new feature, test proxies for more effective integration testing. This is a really cool feature if you're writing integration level tests using PHP Unit. Not every test that you write with PHP Unit is a unit test, and not every test you write with PHP Unit must be a unit test. So integration tests are not bad, they're good, and test proxies make them much more convenient and effective to write. So consider you have a class like the sample workflow class, which integrates with the backend, with a service, and does something with the request object. And you want to make sure in an integration test, not in a unit test, that the right object communication happens. So in a unit test, this would be really simple. We would create stubs and mocks of our collaborating objects, of the request, of the service, of the backend, and have our expectations set up. Everything is fine. But for an integration test, we want the actual code to be executed and not to be stubbed out. And this is where test proxies come into play. It's the same syntax as if you were using a mock object. You can say, for this test to be successful, I want this method call with these arguments and everything to happen on this object, but please actually execute the real code because I'm in an integration test and not in a unit test. And that's test proxies. We simplified the stubbing of return values using the will return syntax, which was actually a pull request that had been lingering around for 1.5 years, or was merged 1.5 years before. Just took that long to get merged. Nowadays, something like this would be available to our users within 8 weeks, which is really great. So before, you had to use these 3 lines of code if you just wanted to stop something. And with PHP Unit 4.0 and forward, you just need 2 lines. Makes it easier to read because we're not expecting anything. We're just setting up a stopped return value. Strict mode, or as people outside of Germany call it, the German mode. Which is still a feature that I would at some point really like to turn on by default. I know that's very German of me. Do a location detect. That's, well, don't give me ideas. So a really, really long time ago, I was doing a lot of test reviews of both test suites for open source projects to help the community adopt best practice and tell them, here you're using the tool not as effectively as you could, or the test doesn't test anything useful, could be rewritten like this to be more useful. And of course, in my daily work as a consultant, I do this all the time. And I was getting really, really annoyed about seeing the same problems in test code over and over and over again. And whenever I get annoyed by something, I try to solve it with a feature in PHP Unit, at least as long as it's related to testing. So what I did was added the first feature of strict mode, which gives you a slap on the wrist if you have a test that doesn't test anything. That was the first thing that was in there. If you write a test that has no assertion, that has no expectation on a mock object, has no expectation on an exception that is to be raised by the code under test, then the test clearly does not test anything and should not be considered useful, and should also not yield code coverage, which was, so the tipping point that brought me over the edge of implementing this feature was looking at one test for Zen Framework 1, where running just this one test yielded 40% code coverage for the entire framework. And there was no test whatsoever in there. It was just, let's try to execute as much code as possible without failing. And perfect, we get 40% code coverage for the entire project out of that. Great, we're doing a good job. No, you're not. So I put that into the tool, and over the years, I added more and more features, more and more strictness checks, until it became so much that nobody really wanted to turn it on, because maybe they're interested in getting warnings for one thing, but not for 3 others. So that's why we changed it with PHP Unit 4. Give you fine-grained control over the types of checks that you want. So now you can select, yes, I want to be strict about tests that do not test anything. I want to be strict about unintentionally covered code. I want to be strict about output during tests, or I want to enforce a time limit for a test, which is sometimes really useful. If you have a test and it should be a unit test, then that test should be done in half a second, or even quicker. Set a timeout. And if it reaches the timeout, PHP Unit aborts the execution of the test, marks it as a failure. You get an error. This ran longer, or this wanted to run longer than it's supposed to be running. And we stopped it. The next thing that I would like to add there is something that the engineers at Google have already built for CPP Unit and JUnit, which inspects the code that is run while the test is running. So you can say this test is not allowed to execute code that touches the file system or talks to the network. But so far, Derek keeps refusing my request to implement the necessary functionality in Xdebug to get the data that I need for that. So, yes. OK, and of course, you can also configure that in the XML configuration file. You can still use the big strict mode to turn all of them on, but that's going to be deprecated with PHP Unit 4.5. I want to get rid of the strict mode as a one big thing, and eventually at least turn on be strict about tests that do not do anything by default. I hope people won't hate me for that. Other things that happened with PHP Unit 4, support for patch coverage, which is a really interesting code coverage metric for legacy projects. Let's say you have an application that has been developed for a couple of years, hundreds of thousands of lines of code, no test yet, and developers want to start testing, and looking at the code coverage report for the entire project is very frustrating, 0%. But what usually works, at least for large parts of the code base, is to say, from now on, I want to have a patch coverage of 100%. Every time I change a line of code, I want to have a test for that line of code. And there's a separate tool for a separate command line tool for the code coverage library that PHP Unit uses, PHP COV. And what that can do is it takes the input from PHP Unit about which lines of code were executed while the tests were running, and it takes a patch file, something that comes out of your version control, for instance. And then it looks in the patch, finds out which lines are changed, checks with the code coverage data, and checks, okay, this line has been changed, this line was executed while the tests were running, this part of this line of the patch is covered by a test, that's okay. And it's really easy to integrate in continuous integration and get information at the end of your build. We have a patch coverage of 100%, really easy. And much less frustrating than looking at the 0% from the beginning of your testing effort. Of course, a major version like PHP Unit 4 always gives us the opportunity to break things or remove things that don't work or don't work as expected. So one of the BC breaks of PHP Unit 4 was the removal of support for stubbing and mocking static methods, which never really worked. Although people tried to convince me that it actually worked for their particular cases. I highly doubt that. But anyway, it's gone. Doesn't make sense. PHP Unit 4.1 is a typical release of the 4 series in that it only, or in the 4 series until now, in that it didn't bring any new features, but refactorings. We are currently doing a lot of refactoring for the last 2 or 3 years. Did a lot of refactoring of PHP Unit, break it down in ever more smaller components that can have their own release cycle, that can be tested in isolation from the other components. And, well, I'll talk about the goal of this at the end. So, PHP Unit 4.2 saw an addition to the strict mode. There is now a test for test methods that are annotated with to do, which is sometimes useful. Again, command line option, XML configuration, what you would expect. PHP Unit 4.2, yes, also had some more features. At least and at most, invocation count matches, which are very convenient. We deprecated assert tag and assert select. There's a lot of code in PHP Unit that I'm not proud of, which is to be expected in any project that has run for a decent amount of time. In this particular case, it's code that I didn't write. And I made the mistake about 10 years ago to accept it. It's code that sort of worked, but was not really well implemented. It was not really documented. And people were complaining about the fact that it's not as useful as it could be. So we decided to deprecate it now. At some point in PHP Unit 5, we will remove it. Jeff Welch is currently working on a replacement for this based on Symfony Stomp Crawler component, which takes care of all the hard part of this feature, and we just need to map that to assertions. And refactoring. PHP Unit 4.2 came out around the time when there was a change in PHP to a way that you could, using a hack, instantiate objects without running the constructor, which is something that you should never do unless you build a generic ORM like Doctrine2 or build a stubbing and mocking library like the one in PHP Unit. And at some point, both Benjamin, who works on Doctrine, and myself, we were so frustrated that on a daily basis we had to update our hacks and had version switches because PHP XYZ would behave completely different than XYZ plus 1, and XY plus 1 would behave completely different again. And we didn't want to have this code duplication going on, and because it's one problem, it should be solved in one place. So the first iteration was Ocramius instantiator. And in PHP Unit 4.3, we replaced that with something else. Yes, we replaced it with Doctrine instantiator. It was rewritten and donated to the Doctrine project, and that's what we're using now. PHP Unit 4.4, the current stable release, came out in December. Again, refactoring all the code in PHP Unit that deals with global state. I don't know if you know that, but by default, when a test is run before each test, PHP Unit makes a snapshot of all global states, all global variables, all super global variables, static attributes in user-defined classes, all the language features that you shouldn't be using, but you are using in legacy code. All that code has been moved to a separate package because I wanted it to be reusable. There was at least one request where somebody wanted to reuse that code for a project, and I was tinkering with the idea of building a new tool that could use that code, and what the heck, just refactor it and have it reusable. So there's now a global state component on GitHub that allows you to make snapshots of stuff, which can snapshot even more than PHP Unit could do before. So we're slowly coming into the future. I mean, it's already February 2015, but not release day yet. But let's assume that we had already Friday. So PHP Unit 4.5 will come out. And there's one big new feature in there, in that it has out-of-the-box support for prophecy. Most people that are unhappy with PHP Unit over the last couple of years are mostly unhappy with regards to the stubbing and mocking functionality in PHP Unit. The syntax is not what modern stubbing and mocking libraries look like. The implementation is lacking in some areas. And again, that's one of the parts of PHP Unit that I'm not really proud of. And again, most of it was not developed by me. I was almost done with my implementation of it that was very similar to what Konstantin and his collaborators built with Prophecy a couple of years ago. When I was entering my final year at university and I needed to focus on something else, and somebody sent me a big patch and said, hey, I finished your implementation, and I made the mistake of just merging it back then, or as much merging as you could do with CVS. But yes, so Prophecy is of the alternative mocking libraries that are about like mockery and fake and so on. Prophecy is the one that I like the most, that I find the most useful, and it's basically everything that I would build a new stubbing or mocking library today. So it's a highly opinionated yet very powerful and flexible object mocking framework. And most people that I talked to over the last couple of months while I was working on this integration told me that they are confused by the terminology that Prophecy uses. Well, it talks about prophets and prophecies and revelations. And you chuckle and you laugh and you grin, and yes, it's a little bit funny, but there's a meaning behind it. It tries to steer your thinking in a certain direction. And I'm not sure that we would really need this terminology to affect this way of thinking, but that's the way that Konstantin did it. So a prophet creates prophecies by prophesizing them. Now with the integration in PHP Unit, you do not need to care about the prophet because the prophet is handled and maintained by PHP Unit internally. A prophecy describes how an object would behave. And revealing a prophecy yields the test double, yields the revelation, yields the actual object that looks like the real thing and behaves as you need it for a particular test. But the really brilliant thing behind this is that it applies the fundamental concept of separation of concerns to stubbing and mocking. Before, like with PHP Unit's own stubbing and mocking library, you have one object that has the configuration and the real thing that it tries to emulate. You'd say $this get mock class name, and you get an object that looks like the real class. And in addition to that class's methods, on that object you have additional API to configure its behavior, which is convenient until you have a method of the same name as PHP Unit's API in the original class, which I thought would never happen until, I don't know, 2 years ago when we added the method. Like I said, okay, in this case, it makes sense to have a method named method because we configured the behavior for a specific method on this object that looks like some other object. But then, again, nobody tested release candidates. We released the new version of PHP Unit. And on the first day, I got several bug reports saying, my test suite no longer works because I actually have classes that have methods named method, and everything crashes. That was a tricky one to solve. But with prophecy, we don't ever can run into this problem because we have one object that has the configuration, and completely separate from that is the actual test double that we use as a stub or a mock. So just to give you an idea what the syntax looks like, we're testing the collaboration of a subject and an observer object. So we create our subject. Then we start prophesizing about the observer. So we create a prophecy for the observer. And we say the update method of the observer should be called with this argument. So it's much more natural than what you would write in actual code in the description of your expectation. And your IDE can actually help you with that because you get auto-completion for stubbed and mock methods if you help it a little bit. And then we call the reveal method. When once we're done configuring our test double, we call the reveal method on the prophecy to reveal the prophecy, and we get the test double object and can pass that to our subject, and then it works. And once you get behind the terminal, in reality, you don't really need to work or need to think a lot about the prophet and the prophecy and the revelation. You just need to create your objects and reveal them. But it's very powerful, and of course, that doesn't really show on an example that fits on a single slide. So, what else? PHP 4.5, so built-in support for prophecy, registration of custom comparators for assert equals. So when you use assert equals, what happens internally is PHP Unit tries to find the most specific comparator, like a comparison implementation for the type of variable that you have supplied. In the case of two objects that you try to convert, it looks at the objects to, for instance, figure out, are those two datetime objects? Then there's specific implementation to compare datetime objects. For instance, within a given delta, these two datetime objects should be equal, and if they are within, I don't know, 10 seconds or within 1 day of each other, I will still consider them equal. That's what the datetime comparator does. There is a DOM document comparator that canonicalizes DOM structures and then compares them, and so on. And starting with PHP 4.5, there's a convenient way of registering your own comparators. So this is what, well, the hello world of a comparator implementation. You need to implement two methods. You need to implement accepts, which is basically a way of the comparator telling PHP unit, yes, I can compare these two, and then the actual implementation. So in this case, we assume that we have a class named example, and that has an equal to method, and when that returns true for another example object, then those two are considered equal. Otherwise, they're not equal. And if they're not equal, we need to raise an exception, and that's that. And to actually use that, we need to register the comparator and after our test unregister it so that we don't run into any issues with our comparator firing in other tests where we don't expect it to fire. Over the years, I have added some features that I myself thought stupid, but I gave in to pressure from the internet. No, I will not accept like the Nyan cat result printer in the default PHP unit. But this one actually made sort of sense, at least more sense than a randomly colored cat. So there is now a -- columns command line option. People complained for years about PHP unit only using 80 columns. But screens have gone wider, and apparently some people use their shell at full screen all the time, and they don't want to waste screen real estate, so they want to use all the columns. So if you want to automatically use all the columns that your current shell has, use -- columns max, and it tries to figure out what the maximum amount of columns is. I learned a lot about things that I never wanted to learn while trying to implement that properly. For instance, that Windows only claims to have 80 characters by default in the column, 80 columns by default, but it's actually 79 because it counts the cursor as one. Yeah, don't really want to go there. Apparently it's important for some people, so I implemented it. You'll likely see some performance improvements when you use assert equals a lot, and like most of the time, your test should pass all the time. So unless the test is failing, the comparison should also always be equal. There's a little optimization hack that you can do. It makes the comparison of assert equals faster. Deprecated the strict command line object and a strict configuration setting. And now we're going to the future beyond 4.5. At the moment, PHP Unit 4 is supported on PHP 5.3, PHP 5.4, PHP 5.5, PHP 5.6, sort of supported on HHVM, and it works on PHP 7, or on the current state of PHP 7. So what to do about this in the future? Because it means that we have, in large parts, separate execution branches in the code base to deal with version-specific issues that I really want to get rid of, especially for PHP 5.3 and PHP 5.4, which are no longer actively supported. I also want to use language features that have been added in the last 10 years or so. And I really don't want to care about PHP 5.3 anymore, which for the last 2 years or so, I cannot build without patching it on the recent Linux distributions. Yes, there is Travis, and yes, Travis has a very specific PHP 5.3.3 version, because that's the minimum version requirement for a lot of popular components, libraries, and frameworks. But I don't really want to have to deal with that anymore. So I asked a question. So what if PHP Unit 5 came out at the end of this year and would say only support for PHP 5.6 and PHP 7? Because by the time that December comes around, PHP 5.6 and PHP 7 will be the only PHP releases that are actively supported by the PHP project, according to the time frame. There will be still security fixes for 5.5, but I don't really care about security fixes. Really?
No, sorry, you're right.
So, and PHP Unit 6, maybe a year later, and only support PHP 7. And I expected, again, shitstorm to happen. It didn't happen. Most people say, yes, do it. I don't know if those are the same people that would start complaining once I actually do it, but that's another way. And the only way to find out what the right way to do this would be to provide feedback. When I publish the slides, those orange thingies will be actually links to the issue on GitHub. Provide feedback there. And I think we need something like Go PHP 7, maybe, like we had for PHP 5. It's happening. That's good. And we should really get rid of all that old crap. For PHP Unit itself, there's going to be more refactoring. I hope that at the end of this year, we have separate packages or separate components for the test framework and the test runner. And once we have that, we can completely rewrite the test runner from scratch, have a modern test runner that supports parallel test execution, distributed test execution, randomized order of tests, all the things that we wanted for at least 15 years, or at least I wanted them for 15 years. I'm discussing most of these refactorings, especially with regard to the test runner, with Konstantin and Kieran and others who work on PHP Spec, on Behat, and other test frameworks. And it might just be that we write the foundation for a test runner that is used by PHP Unit, by PHP Spec, by Behat. So we don't individually for each test framework have to deal with parallelization and distribution of workload and so on. Just share what makes sense to share. And yeah, so far we only talked about it. Hopefully soon we start to actually work on it. Separate the framework from the test runner. Already mentioned that. Rewrite the test runner. Yes, important. And I'm out of time. Good. I have time to take questions. Yes. Yes.
I find it strange that you keep adding assertion types and then allow over and above these assertions. I mean, in Java, there's this library called HamQuest, and most frameworks allow using these matchers.
Yes.
And this has the advantage of one, composability, and two, you can pass these matches also, for instance, to match function call arguments.
Yes. So there were at least 2 questions in there. Question 1, why do we keep adding new assertions? And question 1.5 or question 2, other language stacks, other testing frameworks have a different concept like reusable matchers, like HamQuest, which is very popular in the Java world, HamQuest JUnit or JUnit HamQuest. Yes. So, okay, where do I begin? Maybe with the second part. So PHP Unit actually has composable matchers. All the assertions use those composable matchers internally. So assert equals, if you call assert equals, what it does, it creates an object of the is equal constraint type and passes that on to assert that. And assert that is inspired by HamQuest's assert that. So internally, we use this everywhere, and it's also exposed externally. It's also documented that you can do it, but so far in the at least 10 years that this has been around, I saw no test suite that actually uses it. He did. Okay. Okay, good. Other part. So when HamQuest first came out, or first came up in the Java community, I I actually started the Hamcrest PHP project because I wanted to have something similar. There didn't seem to be any interest in that, so I took what I had there and made it the foundation for what I just described before. Use it internally for PHP unit at least, because to me it makes a lot of sense. And it also is the same code for the assertions and the matchers that are used in the stubs and mocks, in the mocks. And why do we keep adding more assertions? I don't know. I try really hard not to. At the end of the day, everything other than assert true and maybe assert false is syntactic sugar. But it's very convenient to have a specific assertion, especially since you get very specific output when something goes wrong. So, for example, look at assert empty. Of course, you can say assert true, empty, and then a string or an array or whatever. But if that fails, all that PHP unit can tell you, I expected this to be true and I got false, which has nothing to do with the domain of what you were testing. You have an array and you want to assert that there are no elements in it. You don't want to get, I got false, I expected true, that doesn't match, it's broken.
But the alternative there would be assert that.
Yeah, and nobody gets in your way of writing assert that, not empty, the array. It just works. Other questions? Okay, thank you.